Hey there, and welcome to this video reviewing some pretty standard algebraic techniques. So when we're looking at algebra, we're looking at some of the base ideas, some of the foundational ideas of anything to do with mathematics. If you do need these skills in order to be able to do a lot of other things. We're going to start this video by just going over some of the things that you should have learned before that you may not be quite 100% with yet. So we're just going to cover these things in this video before we get into some examples, etc. So let's get started. The first thing that we're looking at is the word term. All right. Now, the word term in algebra refers to any part of an expression or an equation. So that could be something as simple as 5x. That's a term. It could be a. That's a term. It could be 7. That's a term. Okay? When we look at these things, we can also look at a fraction as being a whole term. So it might be 3 over a. That could be a whole term. It could have powers in it. It could have brackets in it. These are things that we're looking at as a term. So these are parts of an expression whoops, wrong color, or equation. Okay, these are our terms. Our coefficient is the number part of a term. This is the number part of a term. So, for example, we have 5x. The coefficient of 5x is the 5 part. So the coefficient is the number part of a term, and I'll say it's when there's a multiplication happening, but it's the number part of the term. Let's keep going and look at expression. So expression can be a term on its own, or it can be a number of terms put together. So that's expression. So that could be a term on its own, or terms put together. So that could be something as simple as, say, 3x. It could be 2y plus 4. It could be x plus 1 over 2. These are all expressions. Now, what makes an expression different to an equation is an equation has an equal sign in it. So it's like an expression with an equals sign. Okay, it's an equals, has an equal sign in it. So now we're looking at something such as 2y plus 4 equals 10. That's an equation. It has the equal sign. Expressions, no equal sign. Equation, equal sign. Pretty straightforward stuff. Now, the next thing we're going to talk about very quickly is this idea of like terms. Like terms. Okay, I'll go back to my purple pen. Like terms are terms that contain, all right, the same pronumerals okay, so the pronumerals are that letter part, the letter or symbol part. Same pronumerals with the same powers. So the term has to have the same pronumerals with the same powers. So if you have x squared and x, they are not like terms, they don't have the same powers. So for example, if I have x, moving that around a bit too much, x and 2x, they're like terms, but 2x squared is different, okay? The x and the 2x have the same pronumerals with the same powers. The 2x squared has the same pronumeral, but it is not the same power, so they are no longer like terms. And this becomes important when we are collecting these things together, because when we're multiplying and dividing, it doesn't really matter much, but when we're adding and subtracting, we want those terms to be like terms. Okay, some of the symbols that we use in algebra. Alright, obviously we use plus signs for addition. Get everything to work again. We have minus signs for subtraction. We have divide signs for division. Alright, we also, for this one, use fraction bars. Okay, and for times though, times are not usually seen. So for multiply, we leave the symbol out. Okay, we leave that symbol out. Couple more little things to have a quick look at. The distributive law. So I'll just change my pen color so we can see between them. The distributive law is expanding expressions or expanding grouping symbols. Okay, and I probably should have put some grouping symbols up in the symbols section. So we use brackets as grouping symbols. I'll pop them up there. So with our distributive law, what it's saying is that if we have something such as A outside of B plus C, right, to use the distributive law, we are going to multiply that way and multiply that way. So we're going to multiply both terms inside by the term outside to have AB plus AC. Okay, AB plus AC. And the same is true with subtraction. It is done the exact same way. Factorization, however, involves going the opposite direction. So distributive law, we're expanding grouping symbols. For factorization, we are essentially going back the other way. So it is the opposite of expanding. Okay, and it is about using common factors. So it uses common factors. And we usually try to make that the highest common factor. Okay, we want the highest common factor. So that is the HCF. Highest common factor. Okay, and an example of that one is if we have, say, 3x minus 12. We take out the highest common factor, in which in this case is the 3. All right, that's our highest common factor. So we pop that outside of the brackets, and we take the other factors from each of those terms. So if we take the factor of 3 from 3x, so we divide that by 3, we are left with x. And then if we divide minus 12 by 3 to get the other factor, we get minus 4. So that's how that all works. Couple last little bits before we hit some examples in the next video. We have the associative property. So I'm just going to very quickly cover this one. So this is saying if A times B times C, then the same would be true if we had A times B times C, and also the same would be true if I had B times A times C. So that's just saying all that is true. The commutative property, I'll say that properly eventually. Okay, says that AB is the same as BA. It says that A plus B is the same as B plus A. Now this really only works for the multiplication and addition. All right, so A minus B is not equal to B minus A. Okay, and A over B is not equal to B over A. So that's the commutative property. All right. Now, when we talk about identity, we talk about little things such as, say, A. We'll get there in a second. A times 1 is A, or A plus 0 is A. So these are just things that are just true. Okay. And you should all know inverse. Inverse being the upside down version of something. So we have A times 1 over A equals 1. Okay, A times 1 over A equals 1. Etc., etc. Or something such as A plus minus A is going to equal 0. So these are the opposites. So inverse is basically opposite. Last little trick to think about before this video finishes. We need to remember our order of operations. All right, so our order of operations goes grouping symbols, okay, and then we have our exponents or indices, okay, so that's our powers. And then once we've done all of that, we can get into our multiplication and division. And then we can finish off with our addition and subtraction. Okay, so grouping symbols, exponents or indices, and then from left to right is multiplication and division. Then from left to right is our addition and subtraction. And I'll just pop this in here. And then I'll just pop it in here as well. It is very important to remember in order of operations that multiplication and division are on the same level. So they just go from left to right. It doesn't matter which of those two comes first. And the same with addition and subtraction. It doesn't matter which of those two comes first. They are on the same level and they are after all the others. So you don't do any of your additions and subtractions until the very end in order of operations. Okay, in our next video, we're going to see some examples. See you then.